Hey, all, today we're going to continue talking about graphing lines, but we're going to use different types of lines to answer some practical problems. So by now you should be able to enter some coordinates into Desmos, into a table, and it will graph your coordinates. So we are going to use that ability to graph some points that represent practical situations. So here we're talking about electricity and temperature. And so typically if you're looking at a table like this top row is going to be X values and this bottom row is going to be Y values. And they're going to go together to make points. So there's one point, there's another point, there's a point between them, there's another point here, point between them. So I have 5 points here that I can put into a table, and these points will be graphed for me. And that's what's called a scatter plot. So we're going to create a scatter plot. You may have heard that before. You may have done that before. If not, that's okay. And this is where we can actually use algebra in more practical situations that is often used in quote-unquote real life. And what we're going to do is we're going to graph these, and then we're going to use these to estimate an equation of a line that best represents the relationship between temperature and the amount of electricity we use. It's not going to be perfect. It's not going to go through all these points. It might not go through any of them. But we can create a line that best represents this relationship. So we do that first by putting these data points into Desmos. So we are going to put them into a table by pressing the plus and then table. And then we'll type the X's and Y's in here. And we have to make sure they go together. So the ones that I highlighted that go together, we got to make sure that they go together. So I'm going to pause here and put those in. You should do the same thing. You should play along and create a scatter plot with me. So I created the scatter plot. Hopefully you did the same. And you might be wondering, hey, Mr. Prickett, I don't see any of these points. Weren't they supposed to go on the graph? Well, we can zoom out, and you can see they're right there. And then you can kind of zoom back in on them if you want them to be bigger. And you can see they're not in a straight line. And typically when we make a scatter plot, they're not going to be in a straight line. Things in life don't work perfectly. So we use this scatter plot to create a line, and it will graph this line. And it will give us a good estimate of the relationship that exists between the two things we have here, temperature and electricity use. And so we need to first remember the equation of a line in slope-intercept form that hopefully you've been writing down a lot is y equals mx plus b. If you've been writing that down a lot, this will be a little bit easier. If you haven't been, you should start now. We're going to modify this for Desmos. We are going to say y1 because you can see in Desmos up here it says y1. So when we put y1 in here, we just literally type y1 and it'll make it look like this for us. It's going to know, take all of these values from this column and put them into the equation. And then we are going to use this little squiggly line. And we're going to type m x1 because we have a column that says x1. And then plus b. So we're making sure to label y1 and x1 so that it knows to pull from our table. And we put a little squiggly here. The squiggly in math means approximately. And we said, or I said, that in this graph, in this scatter plot, these lines are not in a perfectly straight line. So we want a line that's approximately represents these. So we used a little squiggly. And so you can do, if you can't find the squiggly on your computer, on your keyboard, I don't believe we have it. If you click the ABC, the squiggly is down here. So you can use it there. It's also on the keyboard. If you want help finding it, I can help you. So then we're going to type mx1 plus b. You can see we get a line. Typically, the mistake people make here is they don't type the ones or they don't type the little squiggly symbol. They type an equal sign instead, and we're not going to get the same result. We need to tell this calculator to use x1 and y1 to help us calculate this line. And it's going to do this complicated calculation that we don't need to know how to do. It's doing it for us. And you can see down here the two most important things under parameters are the slope and the y-intercept. And we can use that to write the equation of a line, this red line, that best represents these data points. It's called a line of best fit. And so I'm going to take that information that the calculator gave me, and we write lines by starting with a y and an x, and I'm going to plug in the slope and the intercept. So it says the slope is 0.477103. And it says the intercept is 5.1771. It's positive. And even though that looks messy, there's decimals, it's not really appealing to your eyes, this is the equation of a line that best represents the relationship that we see between temperature and electricity. This is called a line of best fit. Again, line of best fit. So we've created a scatter plot using a table. We use that table to get the equation of a line of best fit. And that line of best fit best represents the information in our table. And for our purposes today, that's our goal, is to be able to get this equation. So I want you to pause here, take a minute. I would go back into Desmos and I would delete out everything I just did, start fresh, put these data points into a table. My height is X, my weight is Y, and we are going to try and get a line that shows this relationship. So press pause and do that. So hopefully you've gotten these in here correctly. They should look like mine. If you're struggling with how to put the points in, please do raise your hand and ask for help. We're making sure that the right numbers go together. So 4.7 and 101, that is a point. So it would look like this if we wrote it as a coordinate. So 1, I'm sorry for the sloppiness. So there are 6 coordinates, 6 points that we should be putting in here. We are trying to get an equation. So we have to modify this for Desmos so that it gives us an equation that represents this relationship, but it's not going to go through all these points, because if I zoom out, it looks pretty straight, but I'm not sure it's exactly straight. We're about to find out. So I'm going to type in y1 squiggly mx1 plus b. If I don't delete out the last table that I did, then I have to modify this to like y2 or x2 because it's going to be a second table, and that's just going to get confusing. We want to repeat the same process. So let's just always start fresh by deleting everything out. And so I get my slope, 49.4794. And I get my intercept, negative 133.295. And I don't know, it looks like it goes through all those points, so maybe this is a perfectly straight relationship and goes through all of these points. But I would say that writing this equation becomes much easier when I use this method where I plug these into a table and I use this modified slope-intercept equation. And so this equation is our best representation, is our line of best fit for our data set. This is a data set. We created a scatter plot. We wrote a line of best fit. So I have one more to practice. I want you to pause this, put this into a table. Again, clear everything out so you can start fresh. And I'd like you to try and get the line of best fit, the equation of the line of best fit on your own, and then press play and check to see if we got the same thing. So hopefully you got the table in there correctly. Again, if you need help making sure that you get the table in there correctly, ask for help. it's good to double check to make sure you've typed everything correctly. It's really easy to type in one of these numbers wrong and then you get a different answer. Then we do y1 squiggly mx1 plus b. I highly recommend you write that down every time you do a problem and you don't just type it in. We're writing it down, typing it in, reinforcing that that's what we need to use to get this line of best fit. And down here we get our slope and our y-intercept. Never mind these numbers under statistics or residuals. If you want to take an AP statistics class or a statistics class, you could talk about those in a few years. These are the important values, slope and y-intercept, and then we go and we plug them in for m and b. We can change this back to an equal sign, get rid of the little ones on the y and x. And so this is our line of best fit, the equation of the line of best fit, which is graphed here in purple. It's pretty close to all those points, but doesn't go exactly through them. That's why it's just an estimate. And that's that. So if you got it right, give yourself a pat on the back. If you got it wrong and you don't know what you did, please make sure you ask for help. Please make sure you stick around and answer the questions at the end of this lesson. Again, if you need help, please do ask. And then practice is what's going to make this easier. The more practice you do, the easier this becomes. Take your time and good luck.